Bismillahirrahmanirrahim. My name is Dr. Imran Wahid. Today I will discuss with you the hemodynamics of cardiac cycle. In previous lecture I discussed with you the basic fundamentals, chamber arrangements involved in the cardiac cycle. So cardiac cycle is basically defined as a sequence of electrical and mechanical events from the beginning of one heartbeat to the beginning of next heartbeat. So there are two phases of cardiac cycle as I discussed with you, a systolic phase and a diastolic phase. Both the chambers, the atria and ventricles, have both these phases. In atria, the atrial systole, and in ventricle, ventricular systole, and atrial diastole and ventricular diastole. The duration of cardiac cycle, as we discussed in previous lecture, is 0.8 seconds. In ventricular systole and diastole, the systole is 0.3 and diastole is 0.5 seconds respectively. And in atria the systole is 0.1 second and diastole is 0.7 seconds. Just to revise the diastolic phase and systolic phase, let us start from the diastolic phase first. As I told you in the previous lecture that the period of diastole starts, let's say, from the atrium. We can see that in diastole the blood from the upper parts of the body is received by superior vena cava and inferior vena cava from upper and lower parts of the body into the right atrium, and from pulmonary veins into the left atrium, and then the blood is poured into the right and left ventricle through the by the opening of atrioventricular, that is mitral and tricuspid valves. When atria receive the blood, the flow of blood continues to enter when the ventricles are relaxing. Ventricle relax, blood is being pushed into the ventricles from the atria through the atrioventricular valves. So at the end of the ventricular relaxation, the pressure in ventricle tends to increase, and when the pressure increases, you can see that there is a phase of slow entry of blood into the ventricles. So first there is the rapid filling phase, then there is slow filling phase, and ultimately the filling tends to cease. Okay, so this is very important to understand that the filling phases are also rapid filling phases and slow filling phases. Similarly, contraction phases are reduced ejection phases and rapid ejection phases. We will discuss it one by one. So in this photograph you can see that ventricles are relaxed and overfilled and stretched. This is the point where at last moment the atrial systole takes place, as a result of which the ventricular pressure tends to increase. When ventricular pressure tends to increase, they increase, and when they exceed the atrial pressure, the atrioventricular valves are closed. At this point we can see that tricuspid and mitral valve is also closed due to increase in ventricular pressure. Right ventricle not only increased pressure closes tricuspid but also shuts down the pulmonary valve, and left ventricle not only closes the mitral but also shuts down the aortic valve. So there is no net loss. Show that ventricles had fully relaxed and now they are contracting and pressure is being increased, but all the valves are closed. When the pressure in the left ventricle and right ventricle increase and exceeds the pressure, is more than the pressure in pulmonary artery and aorta, the semilunar valves, that is the pulmonary and aortic valves, are opened and blood is pumped into the pulmonary artery and aorta. Ventricles continue to contract and pressure continues to rise. These valves remain open and blood is being ejected from the left ventricle and right ventricle to the rapid and reduced ejection phase. First there is the rapid ejection like rapid filling phase, then reduced ejection like reduced filling phase or diastasis. So having noted these things, it is important to know that the relaxation or the diastolic phase consists of two phases. One is the isovolumetric relaxation phase, when the ventricle continues to you receive blood, and the pressure in the ventricle is more than the pressure in the atria, and mitral valve is closed, and tricuspid valve is also closed, and aortic and pulmonary valves are also closed. This is known as isovolumetric relaxation phase. Then ventricle starts to contract and pressure further increases. Mitral valve and tricuspid valves are closed, and then when the pressure exceeds the semilunar valves, aortic and pulmonary valves, these valves are shut open and blood is pumped out of the ventricles into the aorta and pulmonary artery. This phase of contraction also consists of a rapid ejection phase and a slow ejection phase. Now let us study the graphic changes which take place during the cardiac cycle. This diagram is very important, and I think we should concentrate it with the full concentration and attention. This is a graph which shows, you can see on x-axis 0.1 to 0.3 up to 0.8 second duration of cardiac cycle is being shown. Systole has been marked from this side to this side, and on this panel we have pressures. So let us start with the diastolic phase. This pressure, larger pressure curve with the pressure of the left ventricle, pressure curve of the left ventricle, and the dotted line above it with the pressure curve of the left atrium. This dotted line is the pressure curve of the aortic valve. Here we can see the atrial systole begins. Atrial systole begins. This dotted line is the atrial, shows the atrial systole. The pressure in left atrium increases, and when it continues to increase, when the pressure is in the left atrium continues to increase, the left atrium, the mitral valve closes. The mitral valve closes, the pressure continues to rise in the left ventricle, and when the left ventricle pressure exceeds the pressure in the aorta, the aortic valve opens. Opening of the aortic valve results in this rapid ejection phase. Rapid ejection phase, in blood is pumped rapidly out of the ventricle into the aorta, and followed by this is the reduced ejection phase. When the pressure in of the left ventricle falls below the aortic pressure, the aortic valve closes, and after closure of the aortic valve, a small deflection is produced which is known as dicrotic notch. Then their filling phase begins. This phase is the phase of isovolumetric relaxation, when there is no change in the volume of the ventricle. The pressure continues to fall, and when the pressure of the left ventricle falls below that of the left atrium, the mitral valve opens, and there is a rapid filling phase and reduced filling phase. So these are the important features. To revise, the pressure in the left ventricle increases above the pressure in the left atrium, mitral valve closes, and it continues to rise. When it exceeds the aortic pressure, aortic valve opens, and there is a rapid ejection phase, reduced ejection phase. Similarly, when the pressure falls below the aortic valve closes and the pressure continues to fall until it drops below the pressure in the left atrium, and the mitral valve opens. There is a rapid filling phase and reduced filling phase. But here we can see that when there is a atrial systole, the mitral valve, aortic valve is opened, the mitral valve is closed. But this period where mitral valve is also closed, and this period when aortic valve has not opened yet, this is the period of isovolumetric contraction, when the ventricle is contracting but has not exceeded the aortic pressure. This is known as isovolumetric contraction phase, when the volume remains the same. There is no change in volume. Similarly, here you can see in relaxation phase, the volume remains the same. So this is isovolumetric relaxation phase. This is isovolumetric contraction phase. Pressure increases above the left atrium, mitral valve closes, above the aortic valve opens, falls below the aorta, aortic valve closes, and then it continues to drop till mitral valve again opens when the pressure drops below the aortic or the left atrium, and it continues. Volume changes are important. You can see left ventricle volume. Here, when atrial systole is there, ventricles are receiving blood, so there is increase in the volume. But in isovolumetric relaxation contraction phase, there is no change in volume. only pressure is being built up, no volume is gained or being lost. But in rapid and reduced ejection phase, you can see that volume of blood is being lost from the ventricle and there is decreased in volume. The pressure curve is dropped like this, loss of volume from the left ventricle because it is being pumped into the aorta. Then again, in isovolumetric relaxation phase, the ventricle is relaxing, receiving blood. Mitral and tricuspid valves are closed. There is no net change in volume. When the mitral and tricuspid valves again you can see opens, the volume again starts increasing and the process is repeated again. Here we can see ECD. This is P wave. Before that you can have a fourth heart sound here before P wave. At this phase you can have first heart sound, after T waves second heart sound, and here we have third heart sound. To make it easy for you, I've labeled it here as this is fourth heart sound, first heart sound, second heart sound, and third heart sound. Here you can see left atrial pressure increases, and when the ventricular pressure increases more than the left atrial pressure, mitral valve closes, and it continues to increase. When it exceeds the aortic pressure, aortic valve opens, and when it falls below the aortic pressure, aortic valve closes, and when it again falls below the left atrial pressure, mitral valve again opens. So these are the few important changes in cardiac cycle. You can see these graphs everywhere, but you must remember important points. Number one, the most important point to remember is that isovolumetric contraction means that the ventricle is contracting, pressure is increasing, but since the mitral, tricuspid and pulmonary aortic valves are closed, there is no loss or gain of blood from the heart. Similarly, in isovolumetric relaxation phase, blood has been received from the atria, mitral and tricuspid and aortic pulmonary valves are closed, and there is no gain or loss of blood from the in the ventricles. So isovolumetric contraction phase is very important. Similarly, rapid filling, reduced filling, rapid ejection and slow ejection phases are also important. This is the simple description of the hemodynamics of the cardiac cycle. In next lecture, we will discuss about the electrocardiographic changes and ECGs and other cardiac features of the diseases and the physiological phenomena related to the specialty of cardiology. Listen this video to the end, subscribe this channel and click the bell icon so that you can get the notifications of these videos. I request you again to post in the comments any topic on which you want lectures or demonstrations. It will be a pleasure for me. Thank you very much.